an object or an atom has lost its electrons, then it gains, it will be a deficiency of electrons, then it is having the number of electrons are less than the number of protons. If an atom gains the electron from external source, if it is having more number of electrons, then we can call it as it is number of electrons are greater than number of protons. Number of protons we call it as. That means when the number of electrons are more, then we call it as negatively charged. Negatively charged. Number of electrons are less, then we call it as positively charged body. Positively charged body. Usually the charge comes from the electron, the word from the electron. Deficiency and efficiency of an atom is acting like a charged body usually. Not only an atom, if any object if you are taking, inside the object, if it is number of electrons are more, then we can say that that is negatively charged body. If it is number of electrons are less, we can call it as positively charged body. Right? These two are indicating that one is positive charge, another one is as a negative charge. Okay, one is positive charge, the other one we call it as a negative charge. How we can charge a body? Usually, remember we don't know earlier which is positive, which is negative. Usually number of electrons, if it is more, depends on that, we consider it is a positive. But not, it is negative. Why? According to J.J. Thomson has found at the end of the 19th century that was the electron is having the negative charge. Okay, so that's what the reason arrived later on like this. Now, what I am trying to prove here? Here, how an object gets charged usually. How it becomes a positive charge and negative charge, you have seen that. How an object gets a charge, how an object gets charged body, that we are going to discuss. Before going to discuss the methods of charging of an object, I wanted to explain that properties of charge. What are the properties we are having? What are the properties we are having usually? Properties of charge is nothing but first property, like charges repel from each other. Like charges repel. Unlike charges attract from each other. Like charges repel, unlike charges attract. Means positive repel, negative repel, but positive negative attracts always. This is the universal property. Next, second one. What is that second one? Charge is conserved in nature. Charge is conserved in nature. Charge, how it is conserved? Listen, charge can neither be created nor be destroyed, but it can transform one form to another form. Okay? You never ever destroy the charge or you cannot create the charge, remember. Simple example I can tell you for this. Na is a sodium ion, is a positive. Na plus and plus Cl minus. If these are, one is a positive charge body, other one is negatively charged body. Whenever I'll join these two, then it gives the resultantly NaCl. Then this charge became neutralized, but it is not destroyed. LHS is equal to RHS in this case of the charges. So we can say that charge is conserved in nature. Okay. For example, a positive charge 1, if you are taking, here negative charge 1, you are taking, finally the answer is neutral, right? Right? So That means charge is conserved in nature. This is a property 2. After this, you are having one more, that is charge is additive in nature. Additive in the sense, how a charge can be treated as additive, addable. A charge can be addable when there are a number of charges are available in a space. It can addable. How we can add all the charges? Let us say the third property, additive in nature, means if you are having a number of charges in a particular space, say Q1, Q2 minus Q3 plus Q4, like this, some a number of charges are located in a place. Algebraic sum of these all the charges is equal to 0. The total number of charges, if it is Q in the sense, I can write algebraic sum of the charges Q equal to 0. That means whatever the charges are there, the Q, the total charge Q equal to, I can write up is like this. Q equal to Q1 minus Q2 minus Q3 plus Q4. Means sum of all the charges, whatever it can be addable or subtractable, that can be equal to the Q. Okay, that is we call as additive in nature. Next, it is at every point if you take it, this property is applicable. Charge conserved, charge is additive, and charges like charges equal, unlike charges subtract. So one more property is there. Charge is quantized in nature. What is that? Charge is quantized in nature. What do you mean by quanta?
So is it like an energy packet?
Yeah, quanta in the sense quantized in nature. Quanta means Q equal to plus or minus Ne. Okay, means all the charges which is transporting or which is moving from one atom to another atom, always in the form of packets. Always in the form of packets. It never ever transfer in the form of decimals or in a form of fractions. Means from this formula I can tell you that Q equal to N, where N equal to 1, 2, and so on. That means always charge travels 1 electron or 2, 3, or 4, like a complete number it transfers. 3 electrons, 4 electrons, 5 electrons, it can. It never be 1 by 2 electrons, 0.5 electrons, it never be transfers. Means what we understood from this, always charge which is transferring from one atom to another atom while it is exchanging, it is in the form of integral multiples, we can say. What is the word? Integral multiples. Always it is in a form of integral multiples, never transfer in a form of fractions. These are the properties of charge. This is quantized in nature. Quanta means pocket. Then here Q equal to write plus or minus Ne. Okay. Now here I'll put up one small numerical way. Is that the same quantized in nature? How many number of electrons? Sorry. Does 1 coulomb of charge depends on how many number of electrons? 1 coulomb of charge contains how many number of charges? 1 coulomb of charge contains how many number of charges usually? We know 1 coulomb is a charge is given 1 coulomb. We need to find number, how many number? Okay. So we have a formula Q equal to plus or minus Ne, I need to find n equal to q by e, I'll write, where q stands for 1 coulomb, okay, and charge of one electron is 1.6 into 10 to the power minus 19 coulombs. Coulomb, same, 10 to the power 19, if it comes up, 10 to the power plus 19, and 1 by 1.6. This approximately gives us 6.25 into 10 to the power 18 number of electrons. How much it gives us? 6.25 into 10 to the power 18 number of electrons it gives us. These many number of electrons does 1 coulomb of charge consists. Okay, imagine 1 coulomb consists almost 10 to the power 18, in the sense, imagine after 10 you have 8 into 19 zeros. If you keep that many number of electrons, it will have. Then how much small the electron is? Have you got my point? Yes. Right?
Yes, sir.
This is a 1 coulomb contains how many number of electrons? Next, after this we have, since we know that types of charges, we need to discuss that how an object gets charged. How an object gets charged means the methods of charging an object. The methods of charging of an object. How an object gets charged? Methods of charging. What are the methods of charging? First, we have friction method, means by rubbing, by friction, by conduction, and by induction method. By induction method. By friction, how an object gets charged by the friction method? In the sense, by rubbing two objects. By rubbing two objects. Let us say we have regular example is that comb. We have a comb. When you are using comb, your dry hair, or with your dry hair, when you are combing, then if you are trying to attract this dust particles towards the comb, okay. So what happens after rubbing the comb, trying to attract this dust particles? That means before it wasn't, but after rubbing or after combing, if you keep near the dust particles, it is attractive. Why What is happening? What happens before and after? What was happened?
The
Usually,
static charge.
it's simply can't say the static charge. How that is a static charge? You should have some concept in middle. What happens then? When you rubbed, when you're combing a pen, I'm rubbing with a cloth. I'm taking a cloth, I'm rubbing like this, I'm keeping near the dust particles. Then the pen got attractive power from where? When it is rubbed with any cloth, either the pen has lost its electrons or it gains extra electrons. To neutralize itself, it's trying to take the help of other particles. That's why it is attracting the dust particles. Otherwise, no. Right? So, same way, comb also, after combing, if you keep near the dust particles, it's trying to attract towards that. Okay. So, this is by rubbing two objects. Simple examples already, which we have traditional examples in this, which scientists were told depends on triboelectricity. Okay, what are the electrons which are stored? Those electrons are nothing but we have a glass rod. When you rub with a silk cloth, when you are rubbing with a silk cloth, glass rod will get the positive charge, silk rod will get the negative charge. Imagine glass rod is stronger, then why it got positive charge? But how it loses its electrons? Obviously, this depends on their chemical bonding. Okay, in this, the silk cloth has got number of electrons more, that's why it gains negative charge, whereas glass rod got positive charge, right? So, this is the most traditional example. Not only this, the same thing if you do with the fur cloth and ebonite rod. Fur cloth and ebonite rod. If you see fur cloth and ebonite rod, in such case, how it is? This also cloth, this is a rod. Will happen same thing like before? Let us see. When you rub fur cloth and ebonite rod got the negative charge, fur cloth got the positive charge. Opposite to the silk and glass material. Why is that is rod and this is also cloth? No, it depends on the triboelectricities. What is the triboelectricity? There is an order of electron affinity of materials. There is an order of electron affinity of materials. Okay, depends on that it will be. It is having number of electrons are accommodating in the atom. Okay, this is all happening by friction. These are all examples which we discussed till now. Glass rod with silk cloth. Glass rod will get the positive charge, silk rod will get the negative charge. And ebonite rod and the fur cloth. Ebonite rod will get the negative charge and fur cloth will get the positive charge here. Okay, like that. So many examples we will have additionally by friction process. Apart from the friction, we have conduction. What is a conduction? Conduction is also method of charging when a charged body, if you are keeping contact with the uncharged body, a charged body keeping contact with the uncharged body. What do you mean by uncharged body? Number of electrons equal to number of protons. It's neutral. It's neutral. Okay, means it is having positive charges and negative charges both are same. So it is neutral. That's why we will, when you are connecting a positively charged body, let us say this is a positive charged body, I am connecting to this. Whenever I am connecting to this, what is happening here? Since it is in contact, means conducting, right? All the positive charges moves towards this side. Usually positive charges will not move. Negative charges comes since we have the first property. What was the first property? The first property is that all the like charges repels, unlike charges attract. All the negative charges will move towards this side. Then negative charges is attracted by this positive charge whenever it is coming to the contact with the neutral body. This neutral body will be turned into the positively charged. Positively charged. For example, if you are conducting negatively charged body with the uncharged body, all the positive charges will try to move towards the negative charge. But here what is happening, this whatever it is moving towards that side, these all neutralized by this negative charges. Therefore, here whenever positive charges neutralize, whatever the negative charges are there will be accumulated the other side, then it is negatively charged. This is by keeping contact with an object, there is a conduction process takes place. Which object you are keeping? Charged body with the uncharged body. Whenever you are keeping contact, what happens? Automatically, the electrons or the charge carriers either will neutralize or will pass from one higher potential to lower potential. Okay? Now, this is called charging by conduction method. Okay, usually this happens in anywhere. For example, I have charged this pen by rubbing, but I did not wear any insulated materials like slippers and all. I'm connecting with the earth. Automatically, whatever this charge is there will get discharged by passing towards the earth, by conducting towards the earth. Got my point? So that is nothing but we can say is conduction method. Even from human body also charge can pass. Okay. Next, induction process. The most important process is induction. What do you mean by induction? Friction, by rubbing of a two objects, we are charging an object. Conduction, by keeping contact from charged body to uncharged body, we are charging an object. Coming to the induction process, without keeping contact with the uncharged body by the charged body, we are producing the or we are inducing the charge in the browser. Let us see. That is, you have an object which is connecting with the insulated stand is A, is uncharged. There is a one more object of insulating stand and connecting B. This I am keeping contact with this. I kept contact with that. Now, whenever the moment I get contact, this is the one metal object, this is the other metal object, or both are two objects. Now, I am really charged here near that. This is positively charged. Which is positively charged. So, when I am bringing here, usually I am not touching this. I am not touching this. But what I am doing, I am not touching in the sense what is happening here. Just I kept near to that. Therefore, automatically, in this object, this is positive charge, no? According to the first property of charges, like charges repels, unlike charges attract. From entire A and B, all the negative charges comes and accumulates here. Accumulates here. All the positive charge comes towards this side. Now, all the negative charges has come this side, all the positive charges went that side. Now, what I am doing simply, I am separating this. Whenever I have separated this is having more number of negative charges, this is having more number of positive charges. A will be positively charged, B will be negatively charged at a time. We can induce the charge by using the charged body. Now I am removing this. Okay. It is a process of charging your body without keeping a contact with the charged body to the uncharged body. We are using that. Okay. Now here the same thing I have separated it. Instead of separating, one more method I can use it. That is, I am connecting to the earthing process. What is that earthing? Grounding we call. What is that? Grounding. What do you mean by grounding? Grounding in the sense, earthing in the sense, earth is having the capacity to notice or absorb n number of charges if you give. If you are connecting with the earth, if you want, earth will give you also ocean number of electrons. That is the capacity of the earth. Okay? So you can see here, this is a one object. The moment I have got a charged body near to the uncharged body of these two, A and B, now I am connecting object A to the grounding. This is called grounding. Okay. So what happens? The moment I do grounding, I connected this is grounding, and at the same time I separated this. Okay. All the charges which has come here, positive charges, is neutralized by sending the electrons from the ground. Positive charges will not come now. Electrons is sent. Electrons only movable charge particles, remember. Okay, so from here to here it moved. Therefore, it will be neutralized. And object A and B, this is also removed. A and B both can be negatively charged. Negatively charged. Before A and B by separating, it's positive, it's negative, but here it is A is neutralized, is all the positive charges, whatever the electrons are there, with that it will be negative, and B also having already accumulated electrons, with that it is negative. So this is a way we can do the charging by using induction process without keeping contact with the other object. Okay, so you're all supposed to do without keeping contact with anyone the objects exchanging, right? Because of COVID.
Yes, sir.
Yes.
So this is a one method. Now we are inducing the charge without keeping contact. Let us say these are the how we can generate a charge in the object. We have learned this. Now how we can measure the charge, how we can find the force between the charge. If there is a one charge is there, with one charge to another charge, what is the relation? How the force exerts on one charge by the other charge, which is placed at a particular point. That how it happens usually. That which we need to discuss now. That is basically we need to discuss under the Coulomb's law. Let us take a break 1 minute or few minutes. Then we start Coulomb's law.